Hello, welcome back to My Math Teacher at Home. We're working on Chapter 5 of the Grade 9 Academic Math Curriculum. 5.3, Slope. Okay. We're going to introduce, you can read this on your own. I'm going to give you a chance to read it. Remember, you can download this handout from the description part of the video. Okay, I'm not going to read it to you. You can read it, and I'm just going to describe what's going on. Okay, so this is a coordinate system, and we have the x-axis is the horizontal axis, and we label it with an X and put arrows on the end, and the y-axis, you put a Y on the axis to label it, and you put arrows on the end. And I've just highlighted in red so you can see it better. The origin of this graph is 0, 0 of the coordinate system. It's at 0, 0 where the two axes meet. Okay, this is how we're going to write the coordinates of these points. So point A is over here. This is the positive direction to the right. These values are increasing. That's 1, 2, 3, 4, 5. I can see a 5 here, and that's how I know that. And then over here, I see a negative 5. So I know these are negative 1, 2, 3, 4, 5. And going up, counting 1, 2, 3, 4, 5, and negative 1, negative 2. It's hard to see the negative because it's on the line, but it is negative 2, negative 3, negative 4. All right. This point we would describe from 0, 0. We go 1, 2 over in the x direction, and 1, 2, 3, 4 up in the y direction. So the coordinates for point A are going to be 2 over and 4 up. And that's the coordinate. You should go ahead now and see if you can find the coordinates of all of these points, and then compare it to what I do. Turn off the video and then do it, and then turn the video back on. Okay, point B is 1 over in the negative direction, and it's 1, 2, 3 up. Point C is negative 2, negative 1. Point D is 2 over negative 3. Notice we always say the x coordinate first. E is 1 over 0. F is 4, 1. G, let's look at G. G is 1, 2, 3 to the left, so that's negative 3, and 0 up. Negative 3, 0. Just checking that I didn't make any mistakes here. I'm just copying it down, and then I realized I may have made a boo-boo. Okay, so far so good. And H is at, H is at the origin, 0, 0. And I is 1, 2, 3, 4 over, and 1, 2, 3 down. And we're going 4 over in the negative direction and 3 down. Okay, so those are your answers. Make sure you're able to read all these points and label them, or else the rest of the units can be pretty challenging. Okay, so there's a few things we can observe. One is that we have names for these quadrants. These x and y axes, they split the graph paper into 4 different sections called quadrants. This is the first quadrant. Then we label it counterclockwise is quadrant 2, quadrant 3, and quadrant 4. The x and the y axes divide the coordinate plane into 4 quadrants. In which quadrants are the y coordinates always negative? So if you look here, here's y being positive. So anything up here has a positive coordinate for y. Everything down here is below the height of y being 0. And so these are all negative. So that would be quadrant 2 and quadrant 3 and 4. Quadrants where the x's are negative, well, this is the positive direction for x, so anything over here is positive, and this is the negative direction for x, and so anything over here has an x coordinate of a negative. So that's quadrant 2 and 3. You can also test it by just picking any point here and realizing the x coordinate would be, negative, positive. Yep, that works. And a point down here is negative negative. Okay, that's also true. The next one, the signs of x and y coordinates are opposite. Well, in this quadrant, this would be x is positive, y is positive. In this quadrant, we have x is negative, y is positive. So quadrant 2, they're opposite. Over here, we would go negative in the x direction and negative in the y direction. So they're the same. Over here, we go positive in the x direction and negative in the y direction. So quadrant 4. And so that's the answers to that page. Okay, slope. This is what we really care about. Okay, in many places, the law has specific requirements regarding the steepness of a wheelchair ramp, as a ramp that is too steep is very difficult to maneuver. The slope of a ramp is a measure of its steepness. It is by dividing the vertical change, which is called the rise or the fall, by the horizontal change, which we call the run, from one point to a second point on the line. That's how we figure out how steep something is. So here's what you need to know. We use the letter M to represent slope, lowercase m. It is equal to the rise over the run. We say that is change in y over change in x. That little symbol here is delta. It's a Greek letter, and we use it to mean change. Change in. And we read that as change in y over change in x. Now, if we're going to look at the slope of AB, you would just go to the line that has endpoints AB and you would look at A. How do you get from A to B? Well, I'm going to rise 1, 2, 3, 4, 5. I'm going to rise 5, and I'm going to run 1, 2, 3. So I rise 5, and then I run 3. And so that's how I determined that slope. Now notice, I could have started at B and gone to A. And if I did that, I would have said, okay, from B to A, I'm going to rise or go down -5, and then I'm going to run in the negative direction 3. So that would have been -5, -3, which of course reduces to 5 over 3. So the slopes will be the same. The order of points doesn't matter. You can't get it wrong. Okay, let's try that with slope of CD. Slope from C to D. I'm going to start at C and I'm going to go down 1, 2, 3, 4, 5. So I'm going a rise of -5. And then I'm going to run 1, 2 in the positive direction. So my run is 2. From D to C, we're just going to show that again. I could have said, oh no, I'm going to rise 1, 2, 3, 4, 5 in the positive direction. And then I'm going to run in the negative direction. Notice they're the same. Order of points doesn't matter. Okay, let's continue on the slope of EF. You can just do all of these and see what you get, and then turn the video back on and see if you've got it right. Okay, slope of EF. Slope of EF, I can see the rise and the run. So from E to F, I go -2, and then I travel -3. So I've got arrows to show the direction of travel from E to F. From F to E, of course, they'd both be positive. So rise -2, run -3, and that becomes 2 over 3. Slope of GH. GH, that's an interesting line. That's a horizontal line. Let's see what happens. From G to H, I don't rise at all. So I'm rising 0. But I am running. I'm running 1, 2, 3, 4, 5, 6, -6. or 6, depending on where you start. I'm going to start at H and go that way and call it positive 6. It doesn't matter. When you divide 0 by any number, you're going to get 0. And that's special for horizontal lines. You can imagine any horizontal line to get from one point to the other, you never rise. So you always have a rise of 0. And then the run is some number. It doesn't really matter what number it is, because when you divide 0 by any number other than 0, you will get 0. So the slope of that line is 0, which makes sense. It's kind of like a ski hill, right? You could ski on that. You just would say their slope is 0. It's not sloped at all. It'd be cross-country skiing. Okay, slope of ij. Okay, ij is here. I'm going to rise 1, 2, 3 in the positive direction, and I'm going to run -2. So 3 over 2. And then the last one is slope of KL. Where is KL? Ah, here it is. It's hard to see with all my writing. Let me get it with a pen. I see it here. Okay, KL. Oh, KL is interesting. I rise 1, 2, 3. But I do not run either way. That's a vertical line. Vertical. So I rise 3, but I run 0. Well, I hope by now you know that that is never allowed. You cannot divide by 0. Fatal flaw. That is undefined. We say that it does not have a slope. Its slope is undefined. Different from this line, which does have a slope. It just happens to be 0. This one's undefined. And that's true of all vertical lines, because you can imagine all vertical lines will have some number of rising between them, which is really irrelevant because the run is always 0, and you're not allowed to divide by 0. Okay, a line that rises from left to right. As you go from left to right, this line is rising. This line is falling. This line's not doing either. This line here is falling from left to right, because the first point you get is C and then falls. First point you get on this line is F and then rises. Okay, you're going to notice that all of the lines that rise from left to right, they always have a positive slope. That's because you run positive and you rise positive, or you run negative and rise negative. A line that falls from left to right has a negative slope, and that's because your rise and run are always opposite signs. A horizontal line will always have a slope of 0, and a vertical line will always have a slope that is undefined. Regardless of the points you choose or the order, the slope of a line is always the same. For any two different points, we call them point number 1 is x1, y1, and point number 2 is x2, y2 on a line. This is determining the coordinate points. The slope of the line passing through the points, point 1 and point 2, is given by a formula. So we're going to come up with that formula. We're going to see that in order to figure out this rising difference, this rise from here to here, you would have to know how high this point is. Well, we know how high this point is. It's a height of y2, whatever that number is. And we would figure out what the difference in the height is between that point and this point. So if we can use an example over here, I don't have to count those squares. I can see that if point B is at a value of -4 and 6, if that's the coordinates of its point, and point A is at -6 and 1, I know that this point is 6 units high and this point is 1 unit high. The rise is the difference between those y values. 6 take away 1 will give me 5, the rise value. Notice I did 6 take away 1. So I started with point B and I went and subtracted from point A. Similarly, I have to do the same order if I'm going to calculate the run. The difference between the x distance over could be counted by the squares, or I could just recognize that I just have to find the difference between the x values. So I could say -4, wait, what did I do there? Have I got the wrong spot? Yes, I do. That's at -3. Okay, -3, where am I starting? Did I say A to B? 6 take away 1, -3 subtract -6 is +3. What am I saying? Oh, duh. Sorry. So 6 take away 1 was the difference in the heights, and that was 5. -3 minus -6 will give us +3, which will be the difference in their horizontal distances. Sorry, I kind of messed that up. Okay, so we know the height can be determined by taking the height of this point, y2, minus the height of the second point, y1, or the first point. That will give us the rise. And the run can be determined by the difference in the x's. x2 minus x1 will give us the rise. And then we don't have to count squares, and we don't even have to graph it. So this gives us our formula. Our slope is the change in the y's. Well, that's y2 minus y1, and the run is the change in the x's, and that's x2 minus x1. You could write y1 minus y2, and then this would have to match that. It would have to be x1 minus x2. You always have to have the y's on top because that's the rise, and the run is always the x's, but the order doesn't matter. We use this as the formula, but it doesn't matter what you call point 1 and point 2. You can switch it, so order doesn't matter. Okay, almost done. Actually, that was quite a long video. I think we'll stop there before going on to the next page.